Alright, so what we're doing today is we are looking at factoring still, but we're going to start learning how to divide a polynomial by a monomial. We've done something similar to it earlier on, but again, now that we've done a little more things in between, the stuff might be a little bit easier for you and you're a little bit smarter to handle the more complicated problems, okay? So basically, if you can start to see example number 1 right here, right? And so this is basically what the problems look like, and to divide a polynomial by a monomial, I've given you two steps here pretty much. And so what you want to do is basically in this first step, to be a little more specific, is I'll use example 1. So you see this 16y squared minus 12 all divided by 2. So you want to divide each term. So each term meaning you want to set the top. See how there's two things in the top of the fraction? Each term means write them out again. Okay. But you want to divide it by, you want to divide each of them by whatever's in the denominator. So in this case, it's 2. So the step 1 basically is just saying to split up everything that's in the numerator and to split them up and to just put the denominator over each of them. And so what you also want to do once you get to there is to divide, okay? So 16y squared divided by 2. The 16 can, the 2 can go into the 16 8 times, right? So the first term you're only left with 8y squared. And then minus 12 divided by 2. 2 can go into 12 6 times. And so that's it. And that's what the answer would be. Okay, so hopefully pretty simple. Let's go ahead and look at some other examples here. So here we go with number 2. First step, remember, is to rewrite the problem. Oops, I'm trying to get this centered and it's not working. There we go. Okay, so the first thing to do is to rewrite everything on the top, 28pq minus 35p, and then set each of them as separate fractions, and the bottom of the fraction is just going to be whatever's in the denominator. Okay, so you set the denominator to underneath each of these fractions. Okay, let's change the color here so that we can cancel some stuff out and all that business. Let's do yellow. That looks pretty good to me. Okay, ready? Here we go. So if I set this equal, can you see this? Yellow's not a good color. Or the yellow's too. There you go. Okay, so if you just look at the number part in the first fraction, you have 28 and 7, so 7 goes into 28 4 times, and then you can cancel out these p's, so you end up with just what's left over. You end up with a 4q, okay, minus, what do you have here? 35 and 7, so 7 goes into 35 5 times. The p's cancel out, so I just have a 4q minus 5. Okay, so hopefully these are a little simple for you guys. Hopefully, number 3 gets a little more complicated because I threw in 2 variables, and well, I threw in 2 variables in number 2, but I also have 3 things in the numerator this time. But it's the same principle. Okay, so all you're going to do is you're going to rewrite everything on the top. And then create them as each of them as separate fractions. And you're just going to put these in the denominator here. Okay, let's change the colors so that we can make this easy to see here. Okay, so in the first fraction, the r's cancel out and the s's cancel out, so all I'm left with is just 6 there. In the second fraction, so I still have that minus I carry over, the 18 stays. But what do I have here? I have this r cancels out, and I have r squared, so I'm left with 1 r that's left over. So I'm just going to scratch out that 2 so we know. Same with the s's. I have 1 s down here, which means I can cancel out one of these s's here. So what's left over? 18 rs. And then in this last example, what do I have? I have the r's can cancel, and that's it. So I'm left with a 3 on the top and an s on the bottom. So if this part right here was a little confusing, let's break that down. So I just realized that, oh, and here's our final answer, circle that guy, okay? So again, if this part right here was a little confusing, let's look at this middle term. So the original problem was negative 18r squared s squared all over rs, okay? So the negative 18, I think you guys would be able to see that the negative 18 stays, but the r squared r thing might be a little confusing. So I'm going to change our color again. Let's change it to something red. Okay, so r squared here, you're going to, r squared means that I have two r's being multiplied, right? R times r. So if I have one r on the bottom, that means I can cross out one of these r's, and so I have one r left over. Okay. Same with this one right here. S squared is the same thing as saying s times s, so if I have one s on the bottom, I can cancel it out with one of these, which means there's only one s left over, and so that's how we get that guy up there. Okay. This is a pretty short lesson, so I actually have one more for you, if I can get the page to stay straight. And here we go, okay? So let's rewrite everything that's on the top here. I'm going to start it on a new line. So 4x to the 5th minus 24x to the 3rd y plus 10x squared y squared. And I actually have a negative number in the bottom, but that's okay. I'm going to show you what to do with these guys. So what I want to do is I actually want to take care of this negative right from the get-go. Okay, so in this first term, before we start canceling things out and all that business, in this first term, the negative is going to keep the fraction negative, right? Because we only have one guy here, so only one negative here. So it stays negative. So this is going to become 4x to the 5th negative 2x squared. Whereas in the second one, this combination right here is going to actually turn this sign into a plus, right? The two negatives turn into a plus. So I rewrite it. 24x to the 3rd y 2x squared. So I took care of this negative by combining it with the minus sign that was originally there, right? This minus sign. These two signs are going to make it a plus, so that's why there's no negative anymore on the bottom here. And then right here, the plus and the minus overtakes it, so it becomes 10x squared y squared over 2x squared, just looking like that. Okay. So let's start working on this problem and see how we do. Okay. So the first one, I have the 4 and the 2 can cancel out, and I'm left over with 2. Okay. This is x to the 5th divided by x squared. So remember, we're subtracting the exponents. So, or if you want to do it this way, 1, 2, 3, 4, 5, x, 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 and x. So if I have 2 of them here, I can cancel out 2. 1, 2, and I'm left with 3 there. Okay, so I'm left with a negative 2x to the 3rd. In the next example, I have the 24 and 2, so I'm left with 12 on the top. Then dividing, my dividing rules, I'm left with x on the top, right? Because I do 3 minus 2, and then I have my y that still stays there. Last one, 10 divided by 2 is 5. My x squareds cancel out completely because they're both x squareds, and I'm left with a y squared, so I'm left with 5 y squared, and then that's my final answer there. Okay, so hopefully you don't have any questions. If you do, again, always write them down, and I'd love to help you tomorrow in class, or message me, and we'll try and get those questions cleared up. So short lesson today.